What if I told you? Most off-grid systems aren't actually silent. They just hide their noise so well that you don't notice energy and heat building up. When people think of off-grid living, they imagine silence. No generators, no grid hum, just clean energy flowing quietly into the home. But inside almost every system, the inverter is always working. And that work almost always creates noise, heat, and small inefficiencies. So a truly silent inverter setup isn't just about reducing sound. It's about reducing stress across the entire system. At the beginning, inverter noise seems minor. A faint hum, maybe a fan spinning under load. Most people assume it's just part of the system. But that sound is actually a signal, a byproduct of electrical conversion, internal resistance, and thermal management. And where there's noise, there's usually energy being lost. Let's break down the first major source of inverter noise: cooling systems. Most inverters use active cooling, fans that turn on as temperature rises. The harder your inverter works, the louder it gets. But if your inverter frequently runs hot enough to trigger fans, it's likely operating under continuous stress. The noise is just a symptom. The second major source is electrical vibration, often heard as a hum or buzz from components like transformers and inductors. In lower quality inverters, this vibration becomes more noticeable. It's subtle, but constant. It reflects inefficiencies in how energy is processed. Now, let's talk about a big mistake: oversized inverters in low-load environments. A large inverter running small loads often cycles inefficiently. This creates a pattern of quiet, then noise, which is far more noticeable than a steady system. Ironically, bigger doesn't mean quieter. Another critical factor is installation location. Inverters placed inside living spaces or poorly insulated walls amplify even small sounds. But when properly isolated, mounted on solid surfaces with vibration dampening, perceived noise drops dramatically. Silence isn't just about the inverter itself. It's about how it interacts with its environment. Let's move to heat management. When an inverter runs inefficiently, it produces more heat. More heat triggers more cooling. More cooling creates more noise. The quietest systems are not the ones with the best fans. They're the ones that rarely need them. This is high-efficiency design. A more efficient inverter wastes less energy, generates less heat, and requires less active cooling. That's where true silence begins. Even when no load is connected, some inverters produce faint sounds due to standby circuits. This means the inverter is never truly at rest. Now let's talk about load spikes. When large appliances like fridges or pumps start, the inverter instantly ramps up power output. This sudden change triggers fan bursts. But in a well-balanced system with controlled surge demand, these spikes become less frequent. Every bit of wasted energy becomes heat. So a noisy system is often an inefficient system. Silence is running smoothly within limits. Passive cooling setups are key. Some high-quality inverters use large heat sinks instead of fans, relying on natural airflow. Instead of one inverter handling everything, splitting the load across multiple units allows each to operate at lower stress levels. This approach doesn't just improve reliability. It makes the entire system quieter by distributing the thermal burden. Higher voltage systems like 48 volts reduce current flow compared to 12 volts, improving efficiency and reducing thermal load. Less heat, less noise. A truly silent setup often separates the inverter from living spaces entirely, placing it in a dedicated insulated power room. Silence isn't something you add at the end. It's something you design for from the beginning. Noise reflects how hard your system is working. A truly silent inverter setup uses proper sizing, minimizes idle loss, prioritizes high efficiency, and isolates vibration through smart installation. Because silence is not about eliminating sound completely. It's about removing the conditions that create it. A silent off-grid system isn't just more comfortable. It's usually more efficient, more stable, and longer lasting. If you want more deep breakdowns like this about off-grid systems and solar setups, subscribe to Off-Grid Life Tech.